for your admiration, everything. So yeah, this topic is mainly about deep learning fundamentals. So I'll cover first the basic. So I'll share my screen first. Is that okay, right? Because I created some slides for, for the participants to easily follow everything.
Yes.
So a little bit about myself before starting. So like Claudia told you, I'm originally from Pakistan. I did my undergrad in computer science back in 2007. Then I worked for a software engineering company as a software engineer. I didn't, well, it was fun, but then I had this thing in me to, explore new things, this intellectual curiosity, to dig more into how the world works, how works, how web search engine work. Back then, that was my research interest. So then I went for master's to South Korea. I stayed there for 2.5 years almost. Then moved to Ireland for a PhD. Uh, I applied to different places around the world for the PhD, and Ireland was a good choice. Mainly because I liked the supervisor and the research he was doing over there. After completing my PhD in 2011, 2011, I started the PhD, completed in 2015. So there was this tension whether to go back to my country or stay in Ireland. But eventually I decided to, continue in Ireland. That's a story for some other day. But I'm still in touch with people back home, and how I can help them, because that's something I'm very much passionate about. And the main reason that inspired me to take part is because when Claudia told me that this is for not for profits and people who like to, work for the sector where you don't get money out of the voluntary works, but you just do it for the sake of helping people. That's why I really wanted to, be a part of this. And that's something I always love to do a lot. I myself am part of a not for profit for more than 1.5 year now in Ireland. I did two postdocs in U City, then I went to industry for 1 year and 2 months, and now I'm back again and as an assistant professor. So basically, you can see from my career trajectory that I like academia a lot, although academia sometimes treats people of color, people of minority backgrounds not so well, especially when you're in a country that's not yours. But it's okay, it's a struggle. And knowledge sharing and talking to people, meeting new people is something that I really love. So that's why I'm still going in academia and not giving up. But industry experience was also nice. I'll talk a little bit about that during my talk on but the mindsets are totally different in a not-for-profit sector, in the academic sector, and in the industry. We will cover that, and you might know some of it yourself. So deep learning fundamentals is what we're going to talk about. As you know, you guys are all here. You don't have a lot of background in programming. You are here because you are learning, and that's a very good thing. So the future is all about tech and how even in your efforts you can use technology to create better outcomes for society. And that's also what I teach. Computational social science is all about teaching computational methods for social science and sociology researchers. So that's what we are going to see on what kinds of research can we do and can inspire, and how your work can be furthered using deep learning. So I'll start now. So, okay. Deep learning is part of a huge, bigger technology, and also a very hype term, which we call AI. So I'd like to ask all of you, what comes to your mind when someone says the term AI? It could be anything, any movie, you can write in the chat window, anything that basically comes to your mind. And movies are fine. Most of my students may basically answer me with movie names and TV show names, so that's fine too. I'll open the chat window. Okay. Robots, automation. Anyone else? ML, recommendation systems work on basis of AI. Good. Her movie. Finally, we have a movie. Automizing human interpretations. So you guys are giving very good answers, better than the answers in my uh, AI in society class. Yeah, big data. You guys are giving technical answers. I was expecting more movies, but that's okay. Good. So yeah. So most of your answers are correct from a technical perspective. So it shows that you do know your stuff and what we're going to cover here. But uh, whenever AI is mentioned in the news articles, in the space, in TV, especially, they kind of create this whole sense of that it's going to take over the world. It's something evil. It's not good. It's bad for society. Well, there are some issues, ethical issues that have recently come to light, and we need to be careful when we use AI. I'll cover a bit of that. But overall, in general, it's just a tool, just like social networks are a tool for marketing. When we work for a not for profit, we need to reach a lot of people. And for that, we can use LinkedIn, Facebook, Twitter. So these are just the tools. Similarly, AI is just a tool powered by big data, machine learning, recommender systems technology, all of the names that you said. So very good on that front. Now, the good thing is, or rather, the surprising thing is, a lot of people think that it has influenced the software industry. That's true, but the biggest influence of AI is around different other sectors like retail, like travel, like healthcare, like telecom, oil and gas. In fact, Professor Andrew Ng of Stanford, who is basically known as the machine learning guru or AI guru of in the whole academic world or even industrial world, he says that he cannot think of a single industry that has not been impacted by AI anymore. And it's if you equip yourselves with the right skills in AI, you're going to be very, very valuable for industrial jobs, for all of these sectors. And even, there is a company, Zalando, which started out as a fashion outlet, as a something that could sell luxury brands, but eventually all they are hiring, if you go on LinkedIn for their job section, and you're gonna see that uh, all uh, all of their work is now around. Sorry, I my computer got a little stuck. Okay, sorry. So all of the hiring is now for data scientists. Now that's surprising. Something that started off as some website that would sell clothes, shoes, branded purses, is now mostly looking for data scientists or people who are equipped with AI. That's how valuable it is. Now, where are the myths coming from? Are they completely unfounded? Is there any substance to it? Why people you are making you scared of AI? Why are the movies all talking about evil robots taking over the world? It's basically because AI, when we talk AI, it's two kinds of AI. And most of the progress has been made in ANI, which is artificial narrow intelligence, and it's artificial general intelligence that the journalists wrongly perceive, or the people who make those movies and all. So there is, first we have to understand what's the difference. Like all of the examples you mentioned, Google search engine, recognizing images, faces from images, recommending products, recommender systems, those are from the domain of artificial narrow intelligence. And these are small, teeny tiny self-contained tasks, which over the years, and especially with the advent of deep learning, computers have become very, very good at. And that's where most of the progress is being made. Like, for example, writing whole new stories. There is an algorithm, GPT-3. I don't know if you know about DALI or not. You put terms monkey eating banana, and it's going to show you a picture, artificially generated picture of monkey eating banana. So that's but again, that's not artificial general intelligence, because for us to achieve artificial general intelligence would mean that the AI is capable of doing everything that we humans do. We humans are very smart. We know when to cry, we know when to laugh, emotional intelligence, different kinds of intelligence. And we also we when we are given the simple instruction of, say, I want to collect the laptop from the table and put it inside the cupboard. Now that for us is a very simple task, but it can be broken down into many different tasks. And the AI itself would first have to break it down to identifying the laptop from the table, because there might be other objects on the table. So that AGI task needs to be broken down into many ANI tasks, artificial narrow intelligence tasks. And that's a goal that's very far away. Even self-driving cars are in very few locations in some cities, and we have not achieved even that goal. So AGI is something that's needlessly hyped by all those movies, all those journalists. Maybe it sells, fear sells, or I don't know. But the thing is that uh, there is no need to, be scared about AI. Robots are not taking over the world anytime soon. It's going to be still a long time until we reach that goal. So far, what we have is ANI tools that can help us significantly. Now, what drives those ANI tools is a very good answer was machine learning, which you guys already know. Probably you've covered it, because I think I'm 2 weeks in when you've started this fellowship. So the AI is the term that the is used by those people who are in the marketing domain, who want to sell the product, because it's a lot of things, and true AI is still a far-fetched goal. But when the technical people, are going to talk about it, we're going to talk machine learning. And the tasks in ANI that I talked about, self-driving cars, web search, AI in farming, prediction of the crop quality or the harvest in a particular year, all that types of tasks are ANI, and the chief driver behind those tasks is machine learning. So in machine learning, what is your goal? What is machine learning for the simplest, for a layman to understand? It's when you go from an input to an output. For example, you have different news items, and we are living in an age of fake news. We want to label some of them with fake news and some of them with the label genuine news. So the input is the news article itself, the whole content, the title, everything in the text, and the output is whether or not it's fake. A label yes, no. Yes means fake and no means it's not fake. Similarly for email, and that's already happening in your Gmail account. Some of the emails you would see automatically go to your spam folder. So Gmail is already pretty smart at getting spam. Uh, and what does it have to detect the spam? It has the whole email content. Sometimes the origin ID of the email is what it makes the decision on. Sometimes some terms in the email, like money, like a vacation destination. We all have had at some point this email that I'm stuck in this vacation destination and please send me money. So if sometimes it flags these terms and puts it in our spam folder. And sometimes when we miss out an important email, the first place we look at, maybe the spam folder, maybe our Gmail filter automatically marked it incorrectly as spam, because machine learning still can make mistakes. Even with all the progress in AI, it's not 100% accurate. It can never be. Even humans are not 100% accurate, right? We also make mistakes. So why would AI not make mistakes? Another example is whether an ad will generate a click or not. And that's very useful. In fact, 80% of the businesses have their whole AI departments working on this kind of stuff. Google also has an ad department, Meta, Twitter, everyone, because ads are what earns them revenue. So when, let's say, you have the content of an ad, your information about a user, is his or her personal data, what kind of things he looks up on web browsers. So will this particular ad, if I serve to him, will it earn me a click or not? Now, how is all this progress driven in machine learning? By the massive amounts of data that we now have. We know that we generate, because of the web. Even Zoom right now, we are having this call recorded, but it's being recorded somewhere in the cloud. And it's not that Zoom is not going to use our data at some point. It will, and it's going to, make out different products. At some point, it may even create its own uh, repository for machine learning talks, using all the fact that a lot of people are doing webinars on these topics. So data is the new oil. It's, you may have heard this term. Why is it the new oil? Because it helps us mine a lot of tasks that can lead to intelligent decisions. Basically, AI is driven by data. Now, for the simplest example that's given for machine learning is this one, the most classical example. Let's say you have housing data, and you want to predict the price of a house. So what's gonna be the input and what's gonna be the output? In this case, the input A to B. In this case, our output is B, the price. We want a mapping from the price, for the price, and the inputs can vary depending on what we have available. But mostly we have size of the house in square feet, number of bedrooms, number of bathrooms, whether or not it's newly renovated. Now, even this simple data set of 4 features, these would be called the features, and this price is the target that we want to predict. Even this data can uh, give us pretty good accuracy about some price. And of course, we won't have this small of a data set. I just have to show you new slides, but usually we do have thousands of such data items. Even if you go to property price register of Ireland, I'm sure you must have something in Netherlands, in Amsterdam too. You just go to the website and you'll find all this data, and you can input it to a quick and dirty logistic regression, or even not logistic regression, a linear regression classifier, and you'll have house price predictions. So why did we need something called deep learning? Where did that come from? So I already covered that AI is intelligence by machines, and like natural intelligence, it means decision making, which treatment to prescribe, what would be the house price, things like that. So even if linear regression was doing good of a job for this kind of data on house prices, this tabular data, where did the need for deep learning come from? Why this whole hype around deep learning? Does anyone know? Can you have your own answers maybe? Okay, I'm looking in the chat window now. Okay. Self-driven car vision. Yes, that's one close answer. Okay. You guys are close. Very good. Yes. But how does it reduce the error is what I'm going to be talking about next. So in its simplest form, deep learning is defined by something called a neural network. Neural network is the simplest block in it. It's at the heart, and the inspiration comes from the human brain, because the way the biological neurons send signals to each other, similarly the neurons do in a neural network. But when we have deep learning, we have neurons stacked on top of one another. Now let's have an example to understand what I really mean, and why even better performance is given when we have a neural network. So let's say me and you, we start this business of selling shirts. We have a website that sells t-shirts, and we want to find out what would be the demand on different occasions of our shirts. And we have different prices. So one way to model this would be, okay, we plot the different prices. We have this data, we plot it on a chart, like a scatter plot. This you may have already done, I think, how to draw scatter plots using matplotlib, and we try to fit a line to it. Now, we know that the trend would be that the higher the price, the lesser the demand. So as the price goes, as I increase the price of something, the demand would go down, few people would buy it. Makes sense. But let's say I have this small round circle that can basically come up with this function. And of course, the demand would not never be zero. It cannot be zero. It cannot be less than zero. It cannot be negative. So we're gonna say that at some point it's gonna flat out at zero. So this kind of uh, uh, blue curve or blue function is what this neuron, which the yellow circle is what I'm calling a neuron, is what this outputs. That's in its simplest form a neuron. And we can do this with a linear regression model as well. But if you see carefully, this is not just a simple linear. We also flat out at some point. With linear, the problem would be it would even go to negative. So like someone said, that it's going to improve our answer and it's going to give a more accurate representation of the real world. That's correct. So this in its simplest form is a neuron, and we go from input A to output B. Now think of it as a Lego brick, and think of it as uh, neural nets and deep learning as many, many of these Lego bricks stacked on top of one another. The simplest would be one neural network, neuron. When we have many on top of one another or layers in layers, that would be a deep learning framework. Let's look at this same example, but a little bit. Let's make it a little bit sophisticated. Now, in the real world, when we're going to have a website that sells shirts or something, we know that it's not just price that's going to drive the demand, right? It's going to be other things too. Other things like, okay, let's say whenever if someone is going to order from my website, there's going to be a shipping cost. Let's say I know the shipping cost. Uh, um, and my customers are very much into affordability. They are not from rich families, or so affordability is a factor. So the price and shipping costs would feed into. Now this again, this blue circle is also a neuron, but this neuron is going to tell me about affordability dimension of my shirts. Now, because I'm running a company, I also have a marketing budget every company has. And that marketing is basically affects the function awareness. Awareness does drive the demand. The more the people know about it. So if there are two competitors, let's say Gucci and who sell purses, or there's another new company. Everybody knows about Gucci. So their marketing team is very strong and they are a brand now. So the awareness is higher. So then marketing would affect this aspect of awareness. Then there's something called perceived quality. Like I said, people think that brands are higher in quality. That's why some people go for brands. They say rather than buying something again and again, it would break down. Let's buy a high-end brand. It won't, it will last me years. That's also one reason for people to go for brands. um, so that's associated with perceived quality. Now price also affects perceived quality. Marketing affects it because the more you spend your budget in marketing, the more the perception that its quality is nicer, and also the material that you use. So then these three blue ones would feed into the final demand thing. So it's you can see how deep learning can mimic the real world factors that go into driving demand much better than a simple linear regression model. Linear regression only models all your data points, all your factors in a very simple framework like AX plus BX. We all studied this in uh, primary school maths, how to plot a linear function. There is just a slope or slopes along different variables, and also constant. But in real world, things are not, very few things depict linear relationships. And even those that do, you have to be very careful. Neural networks, on the other hand, can model the different complex interplays of different factors very nicely, and that's why they're successful. So the answer that to make accurate predictions to better fit the data, yes, that's the correct answer. There's another thing, however, uh, which also drives the power of neural networks or deep learning, is that all of these things about affordability, awareness, and perceived quality, I don't have to think about them. In, of course, some, if I'm from economics, all of these were things from the economics domain. But if I'm just someone who wants to run my business well, or who's a a web designer or a computer scientist who wants to make this demand of my product better, I wouldn't be aware so much about these factors of affordability or awareness or perceived quality. All I want is the data. I have this data, tell me, predict me a demand. So all this beautiful work of the complex interplay of what factors to use where is done by the neural network itself, the deep learning library itself. And that's where the real power comes from. You don't have to get into the nitty gritty details. If you do, of course, you're mimicking the real world better, you're making your model better, but it's not necessary. Even without all this complex knowledge, deep learning does a pretty good job of doing the predictions. Now, let's look at some examples from your own domain. For not-for-profit sector, let's say somebody is working in crisis management, somebody is working on predicting areas where more hospitals need to be built. So what are the data that can go into to drive those predictions or hospital demand? Well, socioeconomic factors do play a role. How much people are on state insurance or how many are on private insurance, that would be a factor. What's their monthly income? That, and all of these data sets are usually available for down to the level of cities, down to the level of districts. And in Ireland, if I give the example of Ireland, for example, there is this research body, ISRI, Economic and Social Research Institute. They, from time to time, collaborate with different not-for-profit organizations, and they build these models, and their models work very well. So for you guys, of course, you're not going to go out after this fellowship and build a t-shirt website or something. But this website was to explain to you that you can think of examples within your domain, say predicting hospital demands, and you want to affect public policy. You want to write a document telling the public that the demand for hospitals in this particular region is more than what we have currently. And you give them this data, you model it with input a neural network, and you give them the numbers. That's going to help the policymakers look into your examples more than when you keep on writing reports with, simple interviews or surveys, or although that's also very useful stuff. But when you actually prove to them with data and with the outputs that, okay, this demand prediction model will fall. Now, S3, for example, in Ireland, their research for, they've been predicting the houses. I'm sure a lot of you know about the housing crisis in Ireland. Ireland is in a mess right now, and a lot of the scientists who work on this data and who have been using the prediction models of machine learning were predicting housing crisis back in 2015. We were surprised when we wrote those kind of news reports, but back then I didn't even read the news a lot. It's something migrants do when they have lived in a long time for in another country. But now when we see it, I recall all those reports, all that research that these different not-for-profits were doing in collaboration with some public policy organizations. So why am I telling you all this, jumping from deep learning to some real world examples, is how this skill of deep learning can be valuable to you. Maybe you can think of more examples when you go back home today or for your project, which will also be a part of this fellowship, I'm sure. So now another, my question was, why did deep learning fly off all of a sudden? And why do we see that it's almost every other industry is now using it? Yes, reducing error in prediction, but even the thing about deep learning, it needs GPUs, and GPUs are not that easily available. And even linear regression would do a pretty good job, even modeling price, shipping cost. So was there really a need? The answer is yes, there was, but not for on data like this. This data can be modeled with other SVMs, say for example random forests, that don't require GPU, that were doing pretty well even without deep learning. And on Twitter, machine learning Twitter, if you guys are on Twitter, you will see that there is this whole debate around use of deep learning for this kind of data sets. This is called tabular data, and most of the business data in the industrial data is still tabular data. But these data sets, like when we have images, when we have speech, when we have text, lots and lots of text, that's where the real power of deep learning comes. For example, now, like I told you about DALI, you just input some terms, monkey eating a banana or monkey in space eating a banana, even that picture will be generated very nicely. I'll give you the link for DALI, and you can try the Hugging Face demo for DALI yourself. It's very fun. So uh, this is called unstructured data. This data of this kind where you have this one in a tabular form and you have sizes and number of bedrooms, number. This is structured data. For this kind of data, the existing machine learning algorithms were also doing pretty well. But when it came to the tasks of image recognition, face recognition, inputting a picture and identifying whether or not to let this guy go through, like you see in movies, the retina scans and the door would instantly open, that's all deep learning. Those kind of technologies were not, linear regression, SVM, and the old machine learning algorithms were not doing so well when it came to this kind of stuff, this kind of data. And that's where a lot of also research is going when it comes to the end not for profit sector. For example, identifying from satellite images which are the regions that are deprived, that are backwards in terms of infrastructure, in terms of roads, in terms of hospitals, in terms of recreational facilities. So satellite images are now easily available. Google Earth Engine has a whole API for researchers. You can download them. So this is idea for another of your project that can use deep learning. So now I was talking about how the machine within deep learning can just take the price, shipping costs, marketing, and the material and output the demand. What can we output here? How is machine learning going to read this kind of data? Now, when we have images, what we see is in this red box, what I'm seeing is the eye of this girl, right? The machine, the computer is, AI is not going to see that. What is it going to see then? It's going to see these sequence of numbers, and each number represents something called a pixel. If it's a grayscale image, the value of this number is going to tell the pixel brightness. If it's close to 255, it means it's darker. If it's close to zero, it's lighter. So if it's grayscale. When we have color images, we have three values. So within one pixel, we're going to have three values, which is RGB: red, green, blue, the primary colors, and which are used to make all the different colors. We know about this from primary school again, that the basic unit, all the colors can be made from the three primary colors, red, green, and blue. So when we have color image, we're going to have in each box, in each pixel, we're going to have three values. But for the sake of simplicity, let's think that this is a grayscale image. Now, what the computer is going to input here is all of these values. And it's like I said, because it is able to model the complex relations with the layers here, with these neurons here, it can model the relations and see eventually there will be not just one layer, other layers. So at some point, it's going to connect the different pixels and come up with, okay, here there should be a closed thing, here there should be this type of eye, this type, and eventually it will make out the whole face and come up with an identity. All of this magic, all of these layers is just like how our brains function, and that's why they're called neural nets, because their inspiration is coming from neurology. And when we tie in a lot of them with each other, just like the Lego bricks, one of them is one Lego brick. When you're going to stack them on top of one another in a complex model, then they'll be called a deep learning network, a deep neural network, and they'll be pretty good at this task of face recognition, which traditional machine learning algorithms are not good at. So say, for example, the accuracy of this thing, of correctly identifying this girl was, say, uh, 56% with a simple uh, SVM. With deep learning, we have gone as up to 88, 90. So that's very good accuracy. Even a lot of hospitals are using deep learning systems to read the MRI scans rather than having a doctor. So it saves you a lot of manual effort. That's why deep learning is so, so powerful. So face recognition is one domain, image recognition, computer vision, self-driving cars are basically, the deep learning is the main technology behind them that has made them so, so successful. So now you see that. And also one more thing, why deep learning has kicked off all of a sudden is that now we do have these images data. If you go 30 years back or even 40 years back, all of this data was not so easily available because we did not have the tools to generate the data. For example, people now upload their images and some of them don't care about the privacy aspect. Some of them do it. So there's still a concern about privacy. And that's where ethical AI or ethical machine learning, this whole new research area is born. But for now, just let's say people are okay with that. So all this new technology to capture the data was not also not available. But now since that's available, that improved machine learning. Now, deep learning are are hungry algorithms. The more data you give them, the better they perform. So that's how they kicked off, and that's how their performance also improved. So does anyone have any questions so far? If you do, you can ask at this point. No? Any any thoughts about a project or something that can use deep learning? Okay. If you do, you can ask at any point. I am having a look in the chat window for. Oh, there is something. Just a quick one. Does the methodology behind factor analysis PCA use deep learning? Not really. That uses something called co-occurrence analysis that was even present before machine learning. But that's uh, chiefly something called factor reduction and matrix computations. So that's not deep learning. Deep learning is when you have all of these stacks together, these neurons working together in a framework. And of course, the matrix computations are also involved here inside, as you'll see in the convolutional neural networks. But chiefly, those are simple computations and simple dimensionality reduction. Uh, but the when in PCA you have if you have hundreds of those computations, in neural nets you would have thousands and even millions. That's what I was going to come to. The other driving factor is the compute power. Now we have lots and lots of powerful GPUs. Even I'm going to show you something called Google Colab. Even a simple Google Colab environment allows you to have access to something called GPUs. And that's also what has made the matrix computations very, very fast. In PCA, for example, you wouldn't have that many computations. So it was okay until then. But then when you had a lot of compute power and a lot of data, so deep learning kicked all of a sudden. And it's not that deep learning is something new. A lot of people think it's new. It's not new. The ideas, the concepts were in papers as old as 1990s. What made people rush to it all of a sudden is, one, the data that we have now, two, the computational power. We have lots and lots of compute power. Now that brings us to another issue of compute power. Do we really need to use all that compute power when we're living in an age of climate crisis? Because all that compute power and all those data centers do generate a lot of greenhouse gases. So that's another area for ethical AI, and that's also something I teach a lot on. So whenever you're using deep learning, make a very, very careful decision on whether it's really needed or not. Image data, text data, yeah, it is, but can we, come up with simpler methods? So that's also one thing as a not-for-profit that you would be interested in thinking about. Any more questions? No. Okay. So another thing is that what we are all discussing so far is supervised learning. So most of the success for deep learning is around supervised learning, where we have labels. Like all of my examples, we have to to train our machine learning algorithm, we have, for the home features, we do have a price associated. And for any new home, it's going to predict the new price. So the labels are the important thing, and supervised learning is a domain. If you're going to go back home today, just Google for supervised learning and unsupervised learning. Unsupervised learning is where you do not have a label. You're going to just look at patterns in the data and put them in different clusters, or like when a preschooler starts to, you give them 5 different shapes, and the preschooler is asked to put those shapes that look together in one box. So you give them 5 boxes, they're going to do that automatically. So that kind of a thing is unsupervised learning. And deep learning's most of the successes that we see around us is from supervised. It's not that deep learning is not applied to unsupervised learning at all. but most of the successful applications you see around are from the domain of like predicting what object is there in image. Is there a cat? Is there a dog? Or is something else? Or when you have audio, there are now speech to text transcription systems, with very good accuracy. Even if you input some of my audio to that system, it's going to, and my accent, of course, is a bit different than a native speaker's accent, but still it's going to predict with good accuracy what I'm speaking. English to Chinese, machine translation, that's also a supervised learning task. In self-driving, when you give it an image and some information from the radar, it can detect the position of, but again, that's also a supervised learning application. So most of the successful applications are around. So when you're going to think about your project, think where you can use the supervised learning and some of the deep learning within images or unstructured data. So now I'm going to go into the different types of deep neural networks just a little bit, because this was about the fundamentals. So basically, I'm going to talk about three basic types of neural networks. The one we saw here on the price and affordability, with layers connected with one another and feeding one into another with simple weight additions. That's called a multi-layer perceptron. And now these have become very fast with the advanced computing technologies, and they perform quite good, mostly for tasks like predicting house prices or tabular data. They perform quite well. Now, the other type is convolutional neural networks for image processing tasks for the domain of computer vision, face recognition technology. These do a pretty good job. How are they different? Now, keep in mind, I talked of neural network as a Lego brick. Now, this is the different types of ways of combining those Lego bricks, and also the mathematical operations that you can do inside those Lego bricks. Of course, when you're playing Lego, you're not doing mathematical operations, but of course we are talking computation. So there are going to be some matrix computations involved. So when you have convolutional neural networks, what's happening inside the layers is that whatever the data is fed into, you apply different convolutional operations. What are convolutional operators? There are different matrix multiplications, and different parts, different regions are treated differently to get different feature aspects and different distinguishing aspects. And those are then fed to another layer, and then summary statistics from those layers are finally fed to the final one. So basically, it's treating your whole data into different regions uh, by using different feature mappings and different applying within these layers, applying complex mathematical operations and getting feature maps. It's a little bit of an advanced concept. That's why I'm going to show an example from code also. I won't teach you how to do the whole PyTorch thing right now. You can find tutorials on it. And I'm going to point you to some resources. After my talk, I'm going to upload some resources on GitHub, which Claudia will share with you. But for the sake of simplicity, you can understand that it's just a way to stack together those Lego bricks in a way that they read the different aspects of this cat's image more in a way to increase precision better than this simple mapping, because this simple mapping is again linear functions, but this is, breaking it down into regions and reading different features. What are the distinguishing features in this part of the cat's face, in this part of the cat's face? So this accuracy of convolutional neural networks for images is way better than the simple multi-layer perceptrons. Yes, there is a probability.
There is a, hi Arjumand, sorry, there is a question in the chat.
Yeah, I just read it, Claudia. So the difference in output, yes, there's sort of a probability, sort of a matrix for each outcome. And that matrix then feeds into the final layer, and then you perform final linear pooling operation on it, and that combines the output into one. So it's a more sophisticated and a better output. And this one, okay, this one is used mostly for text data when we have, for example, we want to predict or we want to find named entities in what are named entities? So when I'm speaking a sentence, sometimes I talk about people, people names, organization names, country names. When you want to mine news articles or find out what are the entities, like let's say I am a not for profit and I am constructing for my government some uh, I want to create a project where I'm going to output the names of those people who have been involved in land mafia grabbing. I'm an NGO in Mexico, and I want to mine all the news articles that will tell the government about that this particular guy who is in your government, or let's say in any, even in Pakistan, there are those types of politicians. So can I automatically mine all the news articles and develop the different connections between the different housing states, different housing projects this guy has started, and the names, his, the various forms of his names that are appearing? People have actually done these types of researches. You'll find papers on it, and their papers have informed government policy. So it's kind of a huge project. I wouldn't recommend doing something for this kind of fellowship, but it's just for an idea. So now the thing is, to find out names of people from text is not an easy job. For us humans, it's very easy. How will a computer do it? For computer, it's just a string of A, B, C's. So that's why in these cases, it needs the output to be sequential, because the computer does know that when the name is occurring, there's going to be a certain format: noun, and then verb, and then adjective, things like that. So it needs to have the sequencing. And when you feed a sequence to a neural network and it keeps memory of the previous sequences, that's called a recurrent neural network. And that takes even more resources to run. But the good thing is that it is very accurate when it comes to mining different things from text, like named entity recognition, and for not for profit domain, even fake news identification, or identifying forged documents from that have been submitted by corrupt companies, or things like that can be used in the not for profit sector. So RNN is a good choice when you have text data. So this, of course, there are more types of networks, and more recently, something called transformers are very famous for text. But I'm not going into that because RNNs also do a pretty good job. And because this was deep learning fundamentals, I'll stick to these three, but there are several others. So keep in mind, for simple tasks of tabular data, go to MLPs, multi-layer perceptrons, if your data is simple, like a database, like a table. If your data is of images, I would recommend convolutional neural networks. And if your data is text data, RNNs do a pretty good job. Now, the good thing is there is a library called PyTorch, and all this functionality of loading the data of the mathematical operations, you don't have to do any of this yourself. You don't have to be a mathematical expert for learning about the different matrix feature mapping I talked about, the matrix computations. All of this is done in few lines of code. I'm going to show you an example in Google Colab, and this notebook I will share with you. So this is the task, a very famous task in image recognition called MNIST. The data is MNIST. So this is an extended version. In MNIST, there are handwritten digits, and you feed these handwritten digits to the computer, and it identifies what's written. This one is extended MNIST, so there are also, in addition to handwritten digits, there are alphabets. So this is an R. You would say, what kind of R is this? It's handwritten. It's dirty handwriting too in this. This is A. This is A because it has been rotated. So if you see like this, then you'll see the it's an A. This is N. It has been turned flipped. So this one is an N. So the ground truth tells you which alphabet is this, and this is the actual image. Now, the idea behind this example is that you feed it, there are like thousands of these images in this data set. You feed it this data set and split it into training and test. Now, what is training and test? Maybe you might have covered it in the other machine learning lectures that you did, but just for an example, like I said, in here, we need these numbers, and for the computer to learn and output what this part, okay, the eyes pixels are like this, the mouth's pixels are like this, the teeth pixels are like this, but it won't learn it immediately with one example. You need to feed it. Let's say we have 1000 images and we need to identify who the person is, or if, whether it's a boy or a girl. Okay. So with just one image, it cannot do the job. It needs to have a training data to find out the patterns in your data, and then it can tell you the answers from the new data. So that data that you make it to learn is called the training data, and the new data from which it tells you new things, it's the test data. Usually that's the terminology that's used in by machine learning researchers or practitioners. That's it. So I hope it's clear. But if you have any questions, please feel free to ask, because I'm going to the example now. Yeah, no, this example of in Colab. So I'm going to stop sharing this screen and share this.
There is a question, Arjumand.
Okay. Maybe, but PyTorch is an example. Okay, PyTorch can have both. PyTorch is just a framework, a deep learning framework, a library which is open source, and it's very easy to implement multi-layer in it, convolutional in it, various types. So PyTorch is that there are other libraries as well, TensorFlow, Keras, but I use PyTorch myself, and I recommend it others because it's very well documented, and it's also you can find code samples very easily. All the help is very easily available for PyTorch, and also nice books, nice tutorials. So it's just a framework to implement all. Like I said, you don't have to do all of this from scratch. You use libraries. So PyTorch is the library that has all these different neural networks. All right. Yeah, you're welcome. So I'm going to share my code just to show you how you can do it if you want to do it. So Claudia, will they do the whole implementation in this also, like a hackathon, or just go with the idea? Or
They will cover something in the specializations that start next week. Yeah,
okay, so it's useful.
and that's more hands-on. So yeah, definitely a good start.
Okay. Okay, so don't worry if you don't understand all of this, because I know I have not covered how to code in Python, what's import, what's all this. Don't worry, you will be covering this, or you will find help on the internet. So whenever you write some Python code, you always begin with some imports. This part basically tells you if you have CUDA available. What is CUDA? Like I said, when you have deep learning, it's always a good idea to have GPUs. And first of all, I'm so sorry, I didn't explain about this environment. What is this? Where am I using this? So I need to share another screen in my Gmail. So here you see, this is my Gmail, right? I had opened the email to get access to the Zoom. So when I go to Drive, can you still see my Drive? Uh,
Yes.
yeah, okay, great. So here, Google Collaboratory, Google now gives something called this thing, Google Collaboratory. So this is basically an environment, a Jupyter lab, like do they know Jupyter lab or not yet?
Yeah, I think most of them are familiar, and they have seen already. They have worked already a bit on Google Colab.
Okay, that's perfect. So Google Colab is a Jupyter lab like environment, but on the cloud, and you don't need to install many of the things like NumPy are already available. If you would do it in your own laptop, you would need to install it first. So it moves away a lot of the hassles of installations and running different things. And how do you select a GPU? You can even take a GPU, and now your deep learning code can easily run here. This is from scratch that I showed you. Now back to the code. So what happens is, first they are applying the transformations on the data. They are writing the transformation functions, and here the data will be downloaded. Now, the good thing about many of the Torch libraries is that it comes with some pre-existing data sets. So one of the pre-existing data sets is this handwritten digits one, E. You can also use the MNIST one, but I'm using the extended one. So this is how it's going to be downloaded. You set download to true, and we have in it training data. And then PyTorch has a built-in data loader, which makes life very, very easy. All you do is pass it a batch size. Now, why do we need batch size? Um, because data sets for, like I said, even one image is comprised of many, 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 many pixels, right? So if you give it many images, it's going to be lots and lots of contiguous blocks. So you have to break down your data into small batches for the computer to load it together in RAM once. Otherwise, it's going to break down and the computer will uh, not be able, its RAM will be full and it's going to hang and you're going to run into problems. So 128, usually I use 32 batch size. They've used this code that I got from the internet has 128, but for text data mostly I use 32 because I use long documents. If you're working with tweets, maybe 128 would be fine. So all of this torch.utils, all of this is, you just need to call these functions just like you call the visualization functions, and it's going to, have your data in train loader and test loader. The shape is this. Look how many images we have in here. We have this many images. 112,800. That's a lot of images. But look, the power of deep learning is that it can easily work on this many data sizes, even within a small Colab environment. You don't even need to use your own laptop, your own GPU environment. So this is again showing some samples from the data. This I already showed you. And then, yeah, this is the model itself. How do you construct the model? So the convolutional layers, like somebody asked a question that, is PyTorch the convolutional or MLP? No. For MLP, you will simply use nn.mlp. Now, what is nn? We imported nn over here, torch.nn. So the PyTorch neural network is imported as here. You don't have to even go in how to get the layers and all. It's going to do it automatically, everything for you. Just some tricky bits would be the sizes. This size, input size, has to match what if it's grayscale, you have to give it one channel because we have one color for one pixel. If it's going to be RGB, you have to give it three channels. So, and the size of this output must be equal to this input and these kind of things. Otherwise, the things are simple enough to figure out. And you also have a lot of documentation, and then you just call your model, you just train your model. So here the model is being trained. When you're going to train the model, you're going to there was something called gradient updates, which is updating the weights and learning, optimizer step, and learning the new weights for each step in the training. And here you're not going to learn gradients. You're just testing on the new data. So basically what this function did here, we loaded some part of the data set as test and some part as training. This is always done when we are developing a machine learning algorithm to test out. And here, if you see, there's something called epoch in machine learning. So you don't do one round, you do many, 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 many rounds, because the more rounds you do, the better its performances get. So we started off with an accuracy of 55, and it increased to 78, which is pretty good accuracy for the handwritten digits. So yeah, that's the code. And this is plotting the loss function each time. The loss function is iterating as it's learning, but in the test data, it's pretty stable because we have learned on a pretty good accuracy, stopped on a pretty good accuracy. The higher the number of epochs, the better the algorithm will do. And also sometimes the batch size also affects it, but be careful about batch size. If you pick it too large, you're gonna get a PyTorch RAM error, which we run into a lot at times. So I guess that's it. Any questions?
So thank you, Arjumand. And while questions come, I have one that, or maybe an invitation to extend a bit more on the ethics related to deep learning. So I know several of the problems that that our participants work on are sensitive problems, and we hear a lot about the dangers, as you say,
Yeah.
of using data and applying deep learning for many problems that touch upon these sensitive topics. So can you tell us a bit more on that
Yeah.
side?
So in Ireland, for example, I'll again give the example of Ireland. There was this proposition for Gardaí. In Ireland they call the police Gardaí, right? So uh, they proposed to use face recognition technology to detect some criminals or drug dealers in some of the areas. And this problem in Dublin especially has been increasing a lot, that some of the regions have become very bad in implementation of crimes. They have become like uh, zones for gang fights, and if you read the news. So police came up with this idea, but a lot of academics then wrote a petition for the government. They said, no, this is a very, very bad idea to use facial recognition technology for the police. Why? Now, of course, they will use the data that's already available that they have. And that data would mostly have people from low socioeconomic backgrounds, Black people, people who are migrants, right? And I'm not going into the reasons why their data set is built like that, but most data sets are like that when it comes to crime algorithms. And it's a huge concern because it could be that they wrongly arrest someone, one of their pictures, because they have repeated, like I said, machine learning learns from, is memory hungry. It's going to learn from previous patterns. So if you give it data about Black criminals, if you give it data about migrants, it's going to arrest more migrants. And it could be that those migrants are very well innocent, or people who are similar in their data set would be from the same socioeconomic areas, and it's likely that their clothes, their patterns of dressing are the same, so you're arresting the wrong people. It's a very, very dangerous technology to get into without any proper testing or making you know unbiased data sets. Your data then needs to be very, very clean. Do you have those clean data sets to be able to implemented it for police technology? No, no, that was something that was a big no-go area, and that's why it's very, very controversial. And there's a whole ethical debate about it, and which is correct, I think. There's a question also. Would you mind? Yeah, sure. You can also follow me on Twitter. Um, I do get back on Twitter as well. This is my Twitter handle, and my email is this. You're welcome. Yeah. So did you know about this, Claudia? Maybe you read about the. I'll also send you the Irish Times article on that, the academic sign.
Yeah, I actually wasn't aware. I wonder if there is anything going on, like any study going on about the housing crisis. That would be also very interesting.
Oh, that thing.
Yeah,
There are, but I don't think many of them are using AI at the moment.
yeah,
One of my colleagues said that we can submit a proposal, but that still is in. They stopped the funding for that scheme that combines STEM with the HSS. So we are looking for some new funding scheme, but most of them are policy experts, social science and law people, but using AI, I don't think they have come up with anything yet.
yeah. And we also have another question. Can we use deep learning to extract, model, and predict reported crime on social media?
Oh yes, there is a lot of research around that. That's less, problematic, less ethical aspects than the face technology one, because here you're going to use the geolocation, you're going to combine it with different other data. And I did see some papers on that. I can send you some of those papers and upload it on the material. Yeah, so the answer for that is yes, you can predict reported crime. Yes, that's happened, that a lot of people have done that kind of research. And then there's another, text mining could also have deep learning application to derive insights from anecdotal data. Yes, yes, and that's also a whole new research area. People are doing that too. Yeah, I'm going to upload those papers. Okay. Anything else?
Yeah, if anyone has any other question, okay. Yeah, when it comes to ethics, uncertainty is always gonna be an issue regardless how big the data set. Is there alternative approaches to address uncertainty and try to leverage the technology even though it is not perfect?
People are leveraging in US. They don't care. So the simple answer would be people wouldn't care, but for to address the uncertainty, that's an active area of research. So you can do a PhD on it, and people are doing a PhD on it. So it's still work in progress.
Yeah, okay. If anyone else has any questions, also you can open your mic, but if there is no more questions, yeah. Okay, then we can thank Arjumand for her time, and yeah, and please, as she has shared her Twitter account and also her email, please, if you need anything, feel free to get in touch,
Yeah,
or
I'll
also
share the
let us
papers
know.
also. Yeah.
Yeah, thank you, Arjumand, for your time and for sharing such valuable information with us.
Yeah.
We
Thank
are
you.
happy to have you.
Yeah, I was happy to be with you. Okay. Thank you.
Thank you.
Bye bye. Bye.
Bye, everyone.
Bye.
Thank you.